Hello, 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 everybody. Welcome to 2.3. Why does it never rate the first time that I want it to? I am your host, Mr. Folly, and get ready to learn what happens when we mix together two different temperature things. So heat flows from hot to cold. So heat, remember, is Q equals mc delta T, where Q is heat, boop, boop, boop. M is mass, of course it is. C is specific heat, and delta T is change in temperature. Now, if hot water touches a cold metal, the hot water loses heat, which the losing heat is the negative part here. And the cold water, the colder thing, will gain heat, and that's going to be positive. Okay, so the way I do this is I set them up negative hot, I always put the hot thing on the left, equals cold. Okay, so 1,500 grams of lava at 1,200 degrees Celsius cools to 1,100 degrees Celsius. And it's heated up 300 grams of steam from 125 to what temperature? Okay, so the hot thing here, notice 1,200 degrees, is way hotter than 125. So that means this is going to be my hot lava. Not me, I can cope. I don't need no lava soap. MC delta T equals mc delta T, and this is steam. So I write the lava and the steam in there so that I keep it straight. So the left-hand side is going to be lava. I'm going to keep my negative side with the mass of the lava, so 1,500. Specific heat of lava. Lava is liquid, and at least it was supposed to, even if I have in there, yeah. So lava is liquid, so its specific heat is 0.35. And the change in temperature here is, I do T sub F minus T sub I. As a matter of fact, I'm going to change my equation right here to, that's still negative hot, to T sub F minus T sub I. And my delta T over here should be T sub F, that's final temperature, minus T sub I, that's initial temperature. So my final temperature is 1,100 minus initial temperature, 1,200. Equals the mass of my steam, 300 grams of steam. Specific heat of steam, I remember, is 0.5. It's on your little table down there. And my final temperature, from 125 to what temperature? T sub F minus 125. So calculators assemble. Let's see what we can do. So negative 1,500 times 0.35 times negative 100 equals 52,500 equals 300 times 0.5 is 150. So I should be able to do that in my head. I can. 150 T sub F minus, and then 150 times negative, 150 times negative 125. That's going to be minus, so this is minus 18,750. So now I'm going to move my 18,750 to the other side. So 52,500 plus 18,750 is 71,250. 71,250 equals 150 T sub F. So then T sub F, I'm going to divide both sides by 150, and I'm praying for a temperature bigger than 125. 71,250 divided by 150 is 475 degrees Celsius. Okay. So what did I do? Negative hot equals cold. I kept everything on my hot side, mass of hot, specific heat of hot, final temperature of hot, temperature initial of hot, and you just kept them organized and then did math in a handful of steps. Okay? So, same deal again for the second one. Honestly, I'm going to do just our lab question. So, I'm going to skip that one. Isn't that naughty of me? Okay, so you're doing a lab tomorrow, and you are going to have boiling water, bubble, 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 and you're going to put inside of it 2 metal cylinders. Okay, and that's kind of this, if this was 2 metal cylinders, but you get the idea. So remember, boiling water is 100 degrees Celsius. Hey, that's 100 degrees Celsius. And if you leave it sitting in there for 5 minutes, then hey, this is going to be 100 degrees Celsius. Does that make sense? So you're going to weigh it. It's 100 degrees Celsius. You're going to put it into cold water, and look what happens. The water warms up because you put something hot in it. Okay, so this is the lab that we're going to do. And this is the calculation we're going to do to get ourselves an A. So what's going to happen is mass of the metal, and I'm going to just emphasize again, this is the hot metal from the boiling water. Okay, the mass of the cold water is going to be in a styrofoam cup. The initial temperature of the metal is 100 degrees Celsius, which is the temperature of the boiling water. And the initial temperature of the cold water, which is in the styrofoam cup. Final temperature of the metal in the water, that's the hottest temperature that it gets. So this, again, is going to be in the styrofoam cup. And then specific heat of water is a constant. So let's take a look at this. So again, we're doing the same thing of negative hot. In this case, we're going to have hot metal. And we have hot metal because its temperature is 100. Okay? So hot metal equals cold water. And the cold water, I'm going to call it, instead of cold, I'm going to call it styrofoam water. So both things are going to change temperature. So negative MC delta T, all of the hot metal, not delta T, parentheses, distribute, T sub F minus T sub I equals MC T sub F minus T sub I, distribute. Okay. So the mass of my hot metal is 25.5. Oops, I lost it already. Mass of my hot metal is 25.5. Negative 25.5. Specific heat of my metal is what I'm looking for. Final temperature of the metal is, again, that's going to be the styrofoam metal, which is going to be 10, minus the initial temperature of the metal, which is 100, equals, now I'm talking about cold water. Mass of cold water in the styrofoam cup, 10. Specific heat of water is 1. Final temperature of the water mixture is, I used the wrong number here, okay? The final temperature has to be the same for both of them, okay? So I used the wrong number. 33, okay? So this is going to be 33 minus the initial temperature of the cold water is 10. That's where I messed up before, okay? So remember, I'm putting it in here. So this would be my styrofoam cup, right? So it's originally at 10, and my styrofoam cup goes up a little bit. So here my styrofoam cup was 10 degrees Celsius, and it ends up being 33 instead of 10 degrees Celsius to 15, okay? And then let's calculator it. So on negative 25.5 times, okay, so this right here is 67. Times 67 is, that's negative 67. Is 1708.5 C equals 33 minus 10 is 23 times 10 is 230. Actually, so C is 230 divided by 1708.5, and I get 0.135 calories per gram degrees Celsius. Metals have specific heats less than 1. And this one does. Look at that. Hey, 0.135. And that's it. And to that, I say toodles. Oh, sorry. Toodles. I was supposed to stop it.